So let's talk about scientific argumentation. This is how science is really done. We've talked about this from time to time. Scientists, they observe, they make laws, ideas, and then they have to convince everybody else that they're right. They're not just, everybody doesn't just believe them. You have to convince somebody that you are right. And that is what argumentation is all about. Okay, so an argument is an assertion or an idea or a position with regards to something that is, we call it a controversy, just maybe something that's not a clear answer. And you have to have evidentiary support, that evidence to support your reasoning, um, so you can convince somebody else of your position. And argumentation is the actual act of convincing somebody or trying to convince somebody of your argument. All right. So in science, we know that science is not a collection of facts. It's really theories that have been developed through experimentation and argumentation, in which we have convinced, a scientist has convinced everybody else that their position is correct. They've kind of proved it through the evidence and the reasoning, and then that is what becomes the theory or the scientific law. Scientists argue to convince others that they have the correct theory. And their theory explains how the data fit together and can be used to predict what's going to happen in other situations. Like the law of gravity. We know, we can predict that if we drop something near the Earth, it is going to fall to the Earth because of that gravitational pull. Okay, so a guy named Toolman, that is his last name, he essentially kind of wrote this down and drew out the basic process of argument structure and argumentation. So you have that assertion or that claim. We usually call it a claim, and that's telling your opinion or your position. Um, and we're going to talk about why you support that position. You also have to have data that support your claim. That's kind of your evidence, right? You have what we call warrants to show how the data leads to the claim. You essentially show that it is warranted, that it does actually lead to your claim. You have backing, and backing shows that your method of connecting your data and your claim, it's legitimate. It's actually true. And then sometimes we have qualifiers and we say, okay, well, this is actually only true in certain times or certain cases. And sometimes you need a qualifier and sometimes you don't. But these are the basic pieces of the structure of an argument. And a lot of these probably seem familiar to you. They seem logical. It's like, yeah, of course you have to have data. You can't just say something. And yeah, you have to show sometimes how the data supports what you're saying, because not everyone just automatically sees it. And then you have to, yeah, okay, obviously I have to be able to prove in some way that this is a legitimate data, it's a legitimate connection. So these all probably seem very simple and basic. So when we talk about argumentation, we're going to kind of talk about reasoning as a large topic. So we're not really going to talk individually about warrants and backing. We're going to talk about the reasoning that connects our data to our claim as a category in itself. So we're not going to really worry about these. We're going to talk mostly about reasoning and reasoning patterns and how we make these connections. So let's go through the process. As an example, we're going to use an idea that somebody came up with. We're going to claim that cheerleading is a sport. Okay, you may believe this, you may not, but that's a good place for us to start, because some people do agree and some people don't agree. So we're going to try and argue this. So now we have to determine an argument to convince other people of our position. So that's our claim. Cheerleading is a sport. So now we need some data. Okay, what's some evidence that's going to actually support my claim? Okay, well, here's some data. There's sports-style injuries happen in cheerleading all the time. There are cheerleading competitions that are judged. You perform cheerleading as a team. You absolutely have to have some athletic style abilities. You're using muscles, you're using reflexes, and your mental acuity all together in order to accomplish your goal. And you have to train. So these are some pieces of evidence that I can use to support my claim that cheerleading is a sport. Now I'm going to reason, okay? We're going to talk about how the data is legitimate and how it connects my claim to my data. So, injuries. If a doctor's report shows cheerleaders are suffering the same kinds of injuries and in the same proportion as other sports, well, then we can reason that it's a sport. If there are team competitions sponsored by major sports corporations, professional organizations, and schools which are judged, rankings are given, trophies are given, there's winners, there's losers, it's all very similar to other sports. And anyone who's witnessed cheerleading or tried it themselves sees that it requires that similar training and use of your muscles and your mental focus as other things that we consider sports. So this is my reasoning. That's how I'm connecting those pieces of data I had to my claim that cheerleading is a sport. And then I might say, are there any qualifiers? Are there specific situations when cheerleading is a sport and when it's not a sport? That would be something that each person could determine for their argument. Am I going to try and say, okay, yeah, in these situations it's a sport, and maybe in these situations it's not? That would be where we would insert a qualifier into our argument. So, once again, we have connected our claim that cheerleading is a sport with our evidence, and we have reasoned through those connections, right? If you don't have evidence, then your claim is merely an opinion. Whether you have reasoning that you think you can reason through or not, if you don't have the evidence, then we are dealing with only an opinion. That's what's important about scientific argumentation, is that you have to have that evidence. And that's what is very important for scientific argumentation, as well as your reasoning. You have to be able to connect that evidence to your claim. You can't just use random evidence that has no basis or connection to your claim. You've got to have that reasoning in order to make a scientific argument. So let's break it down. The claim, right? What is it? It's your statement. It's what you're supporting. It's what you're trying to prove. You want this to be clear and concise, okay? When you're thinking about your claim, you may want to ask yourself, what am I trying to prove? What am I saying is the correct answer? What am I saying is the right decision? All these things help you to determine very specifically what you're trying to prove. Evidence. It's that data that you use to support your claim, right? You have to have evidence. And when you're asking yourself, well, what facts did I consider when I decided on my claim? That's going to be my evidence. What's going to convince others that I'm right? Okay, what facts, what evidence, maybe what other scientific theories support my claim? And reasoning, very important, right? You have to make those connections between your evidence and what you're trying to prove, the way you're thinking. Okay, you can cite scientific theory that connects that evidence, but you are likely to use a specific reasoning pattern that we will talk about later. Lots of different patterns that you use to connect your reasoning, your evidence to your claim. And you might ask yourself, what is the connection between my evidence and my claim? How can I prove that connection? Why should someone believe that my evidence is supporting my claim? And how can I show someone that connection? That's the reasoning, showing someone that connection. So let's developing arguments, right? So what's going to make an argument better? What's going to make it strong? Okay, facts, right? Facts, evidence is going to make your argument strong. Reasoning. Those connections, you have to make those connections. If you make those connections, you're going to have a strong argument. You must make the connections for your audience. Do not expect who you're talking to make those connections themselves. You have to make them for them. That is that reasoning. And be persuasive. Be convincing. Now, stronger, better arguments. Okay, we're going to talk about counter argument. What's a counter argument? Well, this is what others might say is their idea. That might be different from yours. You're going to think about that counter argument. You're going to determine what someone who might not agree with you might believe. Okay, and when you can determine what they might believe that's different from what you believe, you can help to move your argument along. Okay, so if you're going to ask yourself questions, you're going to ask yourself, what's the opposite, or what's an opposing point of my claim? What might someone else believe that is different from what I believe answers this same question or the same idea? And that's going to be very important. Okay? Counter arguments show you're not just looking at something from one point of view. You're open minded. You're looking at multiple sides of the situation. You're going to be stronger in your argument because you can now develop something that will counter or prove against that opposing idea. And we call these rebuttals. So, if you know the counter argument, then you can go ahead and introduce a rebuttal within your argument. So if you know what someone else is going to say back to you or what the opposing viewpoint is, then you can go ahead and show that that opposing point is invalid, that it's incorrect, that it's wrong. That's why counter arguments are important. You can see that other point of view, and then you can create that rebuttal to say, no, 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 no. This counter argument is not correct. It's invalid. And that's what you want to do with a rebuttal. You want to show why someone else's evidence that they're arguing is invalid. So you have to disprove their counter argument, and that's what rebuttals are for. You might ask yourself, why are the opposing views not correct? What evidence that they're using is wrong? What part of their reasoning is not true or not correct or being used inappropriately? All those things are going to help you develop your rebuttals. Very, very good. We're going to make those arguments. We're going to think about counter arguments and make them stronger. Scientific argumentation.